Dear students, so today we will discuss about the maximization case of assignment problem. Okay, we have already discussed what is an assignment problem, why are we using assignment problem, and how to solve an assignment problem using Hungarian method, right? So today this is a special case of assignment problem, that is maximization case. In normal cases, we are trying to find out the minimum processing time or minimum cost, etc. Fine. So today in this problem, it's given that find the assignment of machines to the job that will result in maximum profit. See, maximum profit. Fine. So this is a profit matrix. Okay, so when you are assigning this particular machine, that is machine 1 to job A, then the profit incurred is 62. That is a meaning. Fine. So we are trying to find out what has to be assigned to which. That means which machine has to be assigned to which job in order to get the maximum profit for the whole process, right? So let's see how we will do this. Okay, so first thing, whenever you get an assignment problem, the first step that you need to do is you need to check whether it is a balanced problem or not. Okay, how do we check that? We need to see whether the number of rows is equal to number of columns. Now you have 1, 2, 3, 4, 5 columns and you have only 4 rows, which means that number of rows is not equal to number of columns, right? So here the number of rows is not equal to number of columns, therefore it is an unbalanced problem. Now what should we do in order to make this a balanced problem? Now here number of rows is less than number of columns. So what you need to do is you have to add a dummy row. Okay, dummy row means a row which is having zeros as its elements. Okay, so thus I have added a dummy row. Okay, so this is the 5th row wherein all the elements are 0. Now this becomes a balanced problem because number of rows is equal to number of columns. Fine. Now this particular matrix is a profit matrix. You know that. Okay. Now this is a maximization problem. So whenever you get a maximization problem, what you need to do first is you need to convert it into a minimization problem. How do we do that? Just like how we did in the transportation problem, in order to convert a maximization problem to a minimization problem, first you need to identify the largest element in the given table or matrix. Fine. So out of this, all these elements, which is the largest element? The largest element is 111, right? 111 is the largest element out of all the elements. Fine. So using this, we are going to convert this particular matrix into a loss matrix, or a we are going to convert this maximization problem to a minimization problem, right? So from 101, that is from the largest element, you need to subtract all other elements. Fine. So this is our largest element, so subtract all the rest of the elements from 101 in order to convert it into a minimization problem. Okay, so now I have converted. So that is, now 101 minus 62 will give me 49. Again 101 minus 78 will give me 33. 111 minus 50 will give me 61. 111 minus 111 is again 0. Then 111 minus 82 will give me 29. Similarly, for all other elements, you need to subtract that particular element from 111. So you will get this new matrix. Fine. Now this is my loss matrix. Okay. Now it's ready. Now in order to solve this problem, it is just like we are applying the Hungarian method. Just like any other assignment problem, you need to apply the Hungarian method and solve it. Fine. Okay, so what is the first step of Hungarian method? You need to go for row reduction. After that, column reduction. So row reduction. In order to do row reduction, you need to find out what is row minimum. What is row minimum value? Fine. So in this row, which is the minimum value? The minimum value is 0. And check for the second row. The minimum value is 27. Then in this one, the minimum value is 0 again. And then again in this particular row, the minimum value is 24. And here everything is 111. So the minimum value will be 111. How did you get this 111? Don't confuse. Here you are subtracting each element from 111, correct? Every element. So here 111 minus 0. So this will become 111. Okay. I hope you understood. Okay. So now we have found out the row minimum values. Now the next step is you have to reduce this particular value from each element of the corresponding row. Now 49 minus 0, you will get 49. Again, you have to subtract 0 from all these things, so this will remain the same. Now you have to subtract 27 from this particular row. 40 minus 27 will give you 13. Okay. 27 minus 27 0. 50 minus 27 23. Then 38 minus 27 11. 52 minus 27 will give you 25. And similarly, corresponding elements have to be subtracted from all other elements in the corresponding row. Fine. So you will get the reduced value. This is the table after row reduction. Now what is the second step? Second step of Hungarian method says you have to go for column reduction. In order to find column reduction, you need to find column minimum. What is column minimum value? In this particular column, the minimum value is 0. Again here the minimum value is 0. Here also 0. Here also 0. And again you have 0. That means everywhere in all the column the minimum value is 0. So this table will remain the same. So you have to write the same table here. Fine, same table, there is no change because it is just 0. Okay. Now after doing column reduction, the next step is you have to go for row scanning, and then if required you have to go for column scanning. Now I am going to do row scanning. Fine. So when I do row scanning, okay, when I do row scanning, first I take the first row. Here there is only 1 0, so I have to mark a square there. Fine, and then draw a vertical line. Then take the second row, there is only 1 0, mark a square, draw a vertical line. Third row again only 1 0, mark a vertical line. Fine. Then fourth row there is no zeros, skip that row. Fifth row if you take, there are 2 zeros. Okay, these 2 zeros are not cancelled. Fine. Now the row scanning is done. Now again go for, just check whether all the zeros are met. No, actually these 2 zeros are left out. So again go for column scanning. Fine. When you go for column scanning, the first column you have only 1 0, right? So here you mark this and then draw a horizontal line. Second column is cancelled, third column is cancelled, fourth column is cancelled, fifth column there is no 0. So that is skipped. Okay, so now all the zeros are done. Fine, there is no 0 left out. Now check whether the number of squares is equal to the number of rows. How many squares are there? 1, 2, 3, 4. So the number of squares is 4. And number of columns, rows is 5. Correct? So 4 is not equal to 5. Correct? So number of squares is not equal to number of rows. What does that mean? It means that it is not an optimal solution. When this is not an optimal solution, what you need to do? You have to remember the third step of the Hungarian method. It says that you check for the undeleted values, okay, and identify the smallest undeleted value. Now you have these many undeleted values: 49, 13, 24, 39, 29, 25, 30 and 7. Now which is the smallest undeleted value? The smallest undeleted value is 7. 7 is our smallest undeleted value. So what you need to do? You need to add this particular value, that is value 7, to the point of intersection. Now where is the point of intersection? 1, 2, 3. These are the 3 points of intersection where the vertical lines and horizontal lines are meeting. Correct? So what you need to do is you have to add 7 to these 3 cells. So when you add 7 to these 3 cells, that is last row, second column, third column and fourth column. Okay, so when you add 7 to these columns, it becomes 7, right? 0 plus 7 is 7, 0 plus 7, 0 plus 7. Fine. Then what you need to do? Then you need to subtract 7 from all other undeleted values. When you subtract 7 from all the rest of the undeleted values, 49 minus 7 becomes 42. 13 minus 7 becomes 6. 24 minus 7 becomes 17. 39 minus 7 becomes 32. Again 29 minus 7 is 22. Then 25 minus 7 is 18. Then 30 minus 7 is 23 and 7 minus 7 is 0. Fine. So that is also done. The rest of the values will remain the same. That is what the third step of the Hungarian method says, right? So you have to write as it is. Okay, all other values as it is. 33, 61, 0, 0, 23, 11, 19, 0, 40, 23, 0, 10, 0, 0. Fine. This is our new table. Again, after getting the new table, what you need to do? You need to again go for row scanning and column scanning again. So when you go for row scanning and column scanning, first row only 1 0. So again you have to mark this, delete it. Then second row only 1 0. Again draw a vertical line. Third row only 1 0. So again draw a vertical line. Fourth row only 1 0. Okay, and fifth row again only 1 0. So that is all the zeros are done. There is no more zeros left out. So you need not go for column scanning. Now with row scanning itself, you have reached the optimized solution. Why? Because 1, 2, 3, 4, 5. There are 5 squares. Squares is equal to 5. Rows is equal to 5. So number of squares is equal to number of rows. Therefore, you get the optimal solution. So you can write this is a optimal solution. Fine. So you have reached the optimal solution. Fine. So once you reach the optimal solution, what you need to do? Now you have to go for the assignment part. Okay. Now you are going for the assignment. Fine. When you do the assignment, after getting the optimal solution, you need to check. So first, for the first machine, these are machines and these are jobs, right? So for you need to go for machines and then job. Fine. Okay. So the first machine, you have which job? Job number? Job D, right? For second machine, it is B. So you need to look at the 0, where the 0 comes. For first one, it is D. Second one, it is B. Third one, it is C. Fourth one, it is E. And fifth one, it is A. Okay, that is the assignment. Fine. So you have to write it as such. For the third one, it is C. Then fourth one, it is E. And fifth row, it is A. Clear? So now you have machines and you have jobs. Fine. So again, what you need to do, what we have to finally find out, you have to finally find out the maximum profit. Now look at the particular question. This was our question, right? Now we need to find the profit. You take the profit matrix. Fine, this is our profit matrix, and in this profit matrix, for first machine, it is D. So D, the value is 101. Then for second machine, it is B. So B, the value is 84. So you have to write 84. Then third machine, it is C. For 3, it is C. It is again 101. Then fourth machine, it is E. 4 is corresponding to 80. Correct? Okay. Fifth, there is no machine actually. We have added a fifth row as a dummy row, right? It is 0. Fine. Fifth one, it is A. So what is the value of A? It is 0 because it was a dummy row. Fine. So now you have to add all these things in order to get the maximum profit. When you add everything, you will get it as 386 rupees. So this is the maximum profit. The maximum profit is rupees 386. So this is the value. And from this particular problem, we can also infer one more thing, that is job A. A is corresponding to the fifth machine. Actually, fifth machine is not there. Fine, it is a dummy row. Fine. So you can write job A will be declined. Will be declined as there is no machine, as there is no particular assignment. Other than a dummy value. Okay. So thank you, students.